this is Engineering Project 5, and in this video I'll be going over my soundboard. And this project has taken me so long mainly because while I've been building this project, I've been learning PCB Design, which has caused me to do a bad job of documenting the project. So in this video I'm kind of just gonna do an overview of how I built it, and I'll go over the code and PCB design, thought process, and final product. So first, here's the remote. It involves one HC05 Bluetooth module and then a bunch of through-hole components. And one important thing you should know about this is it uses the same microcontroller as an Arduino Uno. So if you look side by side, go up here and then this right here, they are the same microcontroller, and basically all these components on this bottom area right here all help this microcontroller run. And this is essentially just an Arduino Uno. There is a few components that it doesn't have, such as like this, and like these capacitors. But as you can see, there are some similar components which help it run that are on my custom PCB as well, like this right here. And then most of the components, like these, are like ceramic capacitors, resistors. They're all surface mount, which are like much smaller, and they're like probably along this line. And anyway, so we have a button board. So all these buttons have different corresponding signals, which all go to a digital pin like an Arduino Uno. And basically, whenever one of these buttons is pressed, a signal is sent to this Bluetooth module, which sends it to the remote. And then when the remote receives a specific signal, it will play a corresponding sound. And I'll explain how this works in a second. So if I put that to the side, the remote, on the other hand, it's a little more advanced in terms of it does have a on and off switch, and I put tape here because the light's too bright. But basically, this is a DF player, and it holds a SD card, 16 gigabytes, which stores some MP3 files, 1 through 8, with the corresponding buttons right here. So each button will send a signal, and then the DF player will read it, and then send a specific audio file to this speaker, which will then play the corresponding sound file. And as you can see, there are some similarities. So we're using the same integrated circuit as the Arduino Uno and as the remote, so this one. And then it has all these same parts that allow it to run how it is. And then the only thing different, we have our on and off switch, which I thought was a cool addition. And I would have put one on the remote, but I just couldn't find like a good space to do it without having the remote be too big. So I just decided I would just plug in the battery to turn it on, and then unplug it when I'm done. And then we have our Bluetooth module, which receives, and it's in child mode, other one's in parent mode. Then of course we have our battery, and that's about it for the electronics section of this project. And so now if I put these two things together, so if I first turn on this and then put this to the side, we can see the Bluetooth module is blinking now. And then if I grab the remote and then plug in this to the ground, now you can see this is turning on and its Bluetooth module is on. And then eventually these are going to pair in a second. And then once they've paired, I could click, for example, a corresponding button. Then it plays a sound. So now if I click another button, and so you can see we have 8 different MP3 files, each one corresponding to a different button. And this SD card that holds the files can be modified if you just put it in a computer. And this DF player, it takes only specific naming conventions for the MP3 files. So for example, in this DF card, in this audio SD card, it has 8 different audio MP3 files on it, and one is 001.mp3 all the way through 008.mp3. And I'm not sure if there's a limit on this DF player, but I haven't run into anything. So you should be good to do is at least like maybe 20 MP3 files, and beyond that, I don't know. There wouldn't be any purpose in having any more MP3 files to store on there. But yeah, that's a demo for the project. And if you have any questions about the PCB design or how it works, you can leave them in the comments. I can answer them. And then again, I did do a pretty bad job documenting this, but I will post a link to all the names of all the parts if you were interested in trying to order parts for one of your own personal projects. And so anyway, that's a demo for the project. So yeah. So this is the project folder, and first I'm going to go over the PCB designs, then the source code. So now we can just get right into the remote PCB. And this is, I used a program called KiCad to design my PCBs. And learning this took a bit because of all of the different buttons and things you could do in a PCB. And this is definitely one of the things that took a toll on the time for this project. And also it made it so sometimes I would reach a new obstacle and trying to figure out how to do something, which would cause me to lose track of time and not document as much as I usually do, which is why I haven't been able to document this project as much as I would have liked. But anyway, this PCB design, there's a decent amount of stuff going on. So right now off the bat we have our buttons right here. These are the button mounts that we saw initially on the PCB in the demo. And then over here we have our IC, the same as the Arduino Uno. This is called the ATmega328P-PU. And then all of these components down here, you can kind of see these little lines right here. They represent copper routes or trails in the PCB, which are basically just wires. So imagine like there's a wire that connected this on a breadboard to wherever it goes, like right here. Imagine this is just a wire. And these are usually made out of copper, and they could just conduct electricity so the components can do what they're supposed to do and help the integrated circuit run. So anyway, we go over here. This is our Bluetooth connectors. I just made abbreviation BTCon, and we have our 4 pins. This is just for a classic HC05 Bluetooth module. TX, RX, ground, VCC. Power, this just connects up to a battery. If I want, I could have put a switch in just by making this VCC connected to another that connects to the rest of the circuit, but then put a switch in between. But I just decided not to because I didn't have enough space. And then this originally was a on and off switch, but I just never got it ordered because they're quite expensive. And then over here on both these sides at the top we have our 10k ohms resistors, which just connect to these buttons, and so the buttons don't break from too much current, or too much voltage. And then anyway, besides that, we have our 2 LEDs. These just indicate if it's on. This indicates if the SEK is activated. And then anyway, besides that, that's about it for the remote PCB. And we could also, in KiCad, it has this cool thing where you could actually get like a 3D view of it. And so you could see there's a big resemblance with the physical one, because I ordered it and I sent in these files called Gerber files, which is just the export file notation for ordering a PCB. But you could see we have this. And so yeah, that's about it for the remote PCB. And if you're interested in PCB design, I would highly recommend looking up courses on KiCad because it's pretty interesting. Anyway, besides that, we can go back over to the folder and we can get into the audio player PCB. And so now we have our audio player, and so off the bat you can see we have our on and off switch, we have our power, so this is where the battery's connected, we have our Bluetooth connectors, same as the remote. Then this is a DF player mount. I had to custom make this because there wasn't any footprints, which is basically like the ingrain holes for a component. That's what a footprint is for a PCB. And then so I designed this and it worked, and then I got lucky with that. And then we have our 2 resistors that help they act as a voltage divider for the DF player, so it could work as it's supposed to. And then right here we have our ATmega328P-PU microcontroller or integrated circuit, and then we have our components that hook up to the integrated circuit. And then we have our green LED that indicates if the remote is on or the audio player is on, which is controlled by the on and off switch. And then the reason I had to put tape on this green LED that was down here was because it was shining too bright, because I believe this resistor right here is what hooks up to this, and since it's a very low level of resistance, the lights shined a lot brighter and it messed up the camera and you couldn't really see it and it's just too bright. And anyway, besides that, that's about it for the remote PCB. There's still a decent amount going on, but this really is just connecting to all these components just like the remote. So and actually I could just quickly go over the schematic, which is a more like abstract layout of the components. But basically, for those interested in learning PCB design, this is the bare minimum of what you need to set up a Arduino Uno based PCB. So like if you want a circuit board that does something specific, but you want it to maybe be smaller than like a classic Arduino Uno, you could remake a schematic, then design a PCB with just this configuration. And then you would have to burn the bootloader for the ATmega, but then if you did that, then you can make a much smaller device that maybe does like some specialized task that the Arduino Uno could do, but is too big and it's just more work to set up if you were to use Arduino Uno. But anyway, that's about it for the remote PCB. So now we can get into the code of the project. There's two code files, one for the remote, one for the audio player. We can go over the remote first. So just classic Arduino IDE, and I'll talk a little bit about the bootloader after I go over the code. So anyway, it's not too much to the code. First, we just set all the pin modes to input. We have our begin 38400 because this is the Bluetooth. That's what it begins on. Then we just have our loop. We have 8 if statements, and then it just sends a corresponding signal from 1 to 8. And then if the Arduino Uno were to have like digital pins like it does in its classic version, it's basically if it sends 1. If digital pin 2 is high, then it would send 1 through Bluetooth, and then 2, 3, 4. Then with the digital pins right here, it would use that to indicate with the buttons that were hooked up to the remote. And then we have a delay 200 because it was causing the sound to spam before I added that because there was a little bit of noise whenever I clicked the button. So that just fixed it, and then that's all really there is to the remote code. So now we can go over the audio player code. It's a little more complex and harder because you had to set up the Bluetooth receiving, which is always a little more work. And then we have our library right here, our DF robot, DF player mini. That's the library for it. And then we have our TX pin initialization and RX. And then this is something you have to do for the RX and TX when you're dealing with the DF player. And this is another thing. And then we have our setup. So 38400, 9600. So this is for Bluetooth module. And then I believe this is for the DF player. And then we have our receiving or initialization for the DF player to make sure it's working. And then we just initialize volume. This is all just stuff I found off the website for the DF player that you have to do for it to work. And then we have our availability. And then this basically is just like the last for my Bluetooth remote control car. It just checks if the data can be received. And then from here we have it basically just prints that I was using this earlier because I was having trouble connecting the Bluetooth modules for some reason, and then the DF player wasn't playing the right audio file, so I was doing some troubleshooting. I just haven't removed that yet. And then basically from here it just checks that signal from the remote that was sent, and then if it's 1, and then it plays the corresponding file as is, and then that's all there is to the code. And basically when you say player.play 1, basically what it's actually playing is 001.mp3, and like I talked about previously in the demo, basically it does this from 1 through 8. So like for example, if you go back to the top, this is just playing 008.mp3, and this is just how the DF player works. And anyway, it goes from 0 to 8, and that's about it for the code for the project. And so lastly, how I burned the bootloader was I set up this circuit, and then there's a series of uploading that you're able to do with an Arduino Uno when you connect the core to your computer, and then connect the actual integrated circuit to the Arduino Uno in a way where you could basically just burn the bootloader, which means make the integrated circuit able to accept code and work on its own independently. So anyway, I did this, it was a month ago, so I don't remember too well, but I would definitely recommend looking up a YouTube tutorial on how to burn bootloader for an ATmega 328P PU. And then after you do this, you're pretty much set. And then if you're interested in maybe making your own things with a custom PCB, this is definitely the best step to take for beginning. It certainly was for me. But anyway, besides that, that's about it for this project. If you have any questions about like specific details, I'll be happy to answer them in the comments. But anyway, that's about it.